Hi, and welcome back to the Low Level Devel channel's Gameboy Emulator development series. In the previous video, we created the main PPU state machine. In this video, we're going to start implementing the Pixel FIFO pipeline and render the game background to the screen. So let's get started. First, going on to the Pandocs, we'll take a look at the Pixel FIFO section. Under rendering, there's Pixel FIFO. And if we scroll down, we'll see some information about this FIFO pixel fetcher. So it goes through several different states. It's another sort of internal state machine, and it fetches a row of 8 background or window pixels, and then they'll be mixing with the sprite pixels. So it's got 5 steps. This part I'm not going to implement exactly as it says here. It doesn't really matter so much how many dots each of these take, but it is roughly going to be the same. The different states are the get tile, the get tile low, the get tile high, sleep, and then push. So getting the tile is going to find the tile from the background / window tile location, and there's certain flags that it checks on the LCD-C register in order to validate that. And then getting tile data low is simply getting the low bit of the image, of the line of the image. Then get tile high is getting the high bits for those. And then push is actually pushing the pixels onto the screen. And there's some special cases here that the pixel FIFO has to be full. Pixels are only pushed to the background FIFO when the background FIFO is empty. So there's some good reading here. I'd suggest you just go through it. I'm going to implement it as close as possible as I can, with still keeping things pretty simple. But of course, sleeps. So there's sections here talk about rendering the pixels by mixing the background with the sprite. In this video, we're going to focus mainly on the background side of it, and then we'll do the sprites in another video. But there's some good information here. I'd suggest you read it to really understand the process. So let's start out, and we're going to add a new enum here. This is going to be the fetch state of our Pixel FIFO. So the different states were fetch tile, data 0, data 1, then there was the sleep. I'm going to call it idle, and then push. So these are the different states that it's going to have. Now we're going to add another structure here. So this is going to be for a FIFO entry. So we're going to actually implement the FIFO as well here. So there's going to have a next pointer, and then the U32 value, which is actually that color. So that's going to be the color of the pixel. We'll call that a FIFO entry. Okay, so now we will add our FIFO. So this is going to hold kind of the information about the FIFO. So we'll have our FIFO entry head, and then our FIFO entry tail, and then the size. If you're not familiar with what FIFO is as a computer science term, it means first in, first out. I'd suggest looking it up because I'm not going to really kind of cover the data structures in here. So now I'm going to create a Pixel FIFO context. So this is context about the internal state of the FIFO. So first we're going to grab its actual state value. Then we'll have the FIFO itself. We have line X. There's a couple of different variables we need to keep track of, like what the X value of the current line we're on, the X value that we've pushed out, the X value that we're currently fetching, and then the background fetch data. This is like the different tiles that we're fetching temporarily, and fetch entry data. This is the kind of OAM data that we're temporarily fetching for sprites. We'll have the map Y, map X, and the tile Y, and the FIFO X. And I need to put this inside of our PPU context as well. So I'll just add that inside a PPU context so we can fetch it from there. I'll just call it PFC. Okay, now moving on, that should be all the changes for our PPU.h. So now if we go into our PPU, I don't know, what is this complaining for? Did I miss something here? I don't think so. Yeah, it looks fine. Okay, I'll just ignore that red line for now. Sometimes Visual Studio Code gets a little fussy. So I'm going to set PFC line X to 0, and it's not seeing PFC. Strange. Everything looks fine. I didn't forget a semicolon, did I? No. Well, I'll just go ahead with this. Actually, let me do a make. Sometimes a make will actually kind of help clear things up in Visual Studio Code. So let me clear that again. Yeah, there you go. Looks good now. Okay, so now let's moving on. PFC. Now the pushed X we're going to set to 0. We're essentially going to be initializing a bunch of this stuff to 0. Okay, so let's just go through and initialize all these. And this is again in our PPU init. And our current state starts at tile. Let's just make sure this works. Okay. So yeah, we can still build it. Alright, so now let's move into the PPU state machine.c. So now this is going to change. We need to add some initialization here. So before, when we're moving to this X for state, which is where the actual pipeline runs, then we need to set some of these initial values. And this whole part changes. So now we're going to say if the pushed X is greater than the X resolution, so we've pushed all the pixels that we can push, that's when we set the next mode to H blank. And up here we're going to call a function called pipeline process. And then in here before we H blank we're going to call pipeline FIFO reset, because we're done with the FIFO process. So now after we're setting this H blank, we're going to check if the H blank stat interrupt is set. If so, then we're going to request that interrupt. Now we need to implement these two functions. So I'm going to create a new file calling it ppu_pipeline.c. So in here is where I'm going to implement those functions that we defined there. So to start with, we had void pixel FIFO push. This is more of an internal function. This is going to be pushing a pixel to the FIFO. So it's some kind of standard linked list style creation here. We're just creating an entry, setting its next value to null, and setting its value to the value passed in. Pretty straightforward linked list implementation. Now if the PPU get context pfc.pixelfifo.head, if that is not set, that means this is going to be the first entry. So in that case, we can just, let me copy this. So we'll say pixel FIFO.head equals pixel FIFO.tail equals next. That's the value we just added. Otherwise, we need to add it to the tail. So the tail next equals next, and then tail equals next. So that's how we kind of append onto the back of the FIFO. Tail equals next. And now we need to increment the size. So now that we know we have one more in our FIFO. So now if we have push, we need pop. So that pop will, again, take one off. So if for some reason we're trying to pop and the size is empty or less than 0, which of course it shouldn't be, then we'll just print out some error and just terminate because we know something went wrong. So otherwise, the popped value I'm going to just call pixel FIFO head. So that's going to be the value that I'm going to pop, and now I'll say head equals popped next, and the size minus minus. So now we've popped it off. Let's grab the value so that we can return it, and then free the memory for that, and then return the value. Okay. Now moving on, we need to implement our process function and a fetch function as well. So fetch will actually be used by process, I believe. So yeah, let's take a look at that function. So void pipeline process. This is the one that was called from the exfer state. So, and here we need to loop through different states. But first let's grab some variables. First we're going to grab the map y, and that we're going to get from the LCD context ly plus the scroll y. Okay, so that will give us the map y. Now we'll do map x. It's going to be similar. No, that's the wrong value. I pasted it in. Let's see. Yeah, fetch x. So we're going to grab the fetch x plus actually LCD get context scroll x. So that'll give us our map x. So now the tile y, that we're going to get from LCD get context ly and we're adding the scroll y, but we need to do a modulus 8 and then multiply by 2. So that'll give it, that gives us the y value that we're on that current tile. Now we need to do something on every other line, so I'm going to grab line ticks and I'm going to check that first bit. Actually it's not the caret, it's and. So if that first bit is set, then I know that I'm on a, that would be an odd line, so I want to do it on an even line, so I'll say not. So if that first bit is not set, then I know I'm on an even line. So in that case, I'm going to call pipeline fetch. And pipeline push pixel is going to happen every time. So the pipeline fetch happens every other tick, but the pipeline push pixel happens every tick. Hopefully that makes sense. So now we can implement the push pixel and the pipeline fetch. So these two. So pipeline fetch is going to be our main state machine for the pipeline, and this push pixel is going to be actually pushing the pixels onto the pipeline. So let's say pfc.pixelinfo size. If the size is greater than 8, okay, then that means that our FIFO is full and we can start pushing those pixels. So we're going to pop a pixel off the FIFO. Let me just copy this again. So now if the line X is greater than or equal to our LCD contexts scroll X %8. So now we can start pushing this to the video buffer. And where are we going to put it at? So we're going to put it at the video buffer pushed X plus, let me reformat this sum. So LCD get context ly times X resolution equals pixel data. So that pixel's at that location in the video buffer, and now we need to increment our pushed X because now we've pushed a value that needs to be incremented. And then our line X can be incremented in both cases. Okay, so that now moving on to the pixel fetch. This is going to be the more kind of complicated one. So we're going to start by switching through each of our states. So we'll grab our current fetch state. So we're going to have the FS tile. And if you remember, there's 5 states. So I'm just going to paste these here. Let's say, yeah, I'm going to put brackets around them. Let's just do it like this. 4 or 5. So we have tile, then we have data 0, data 1, idle, and the push state. So for FS tile, we need to actually fetch the current tile for the location that we are on the map. So first we want to actually make sure is the background and window enabled, because if they're not, then we don't want to grab anything. So if so, let me PFC, copy this. Okay, so if so, we're going to, if you remember this array of fetch data, the 0 item is going to be from the tile. We're going to call bus read for that map area plus, so the map area is the starting area to read tiles from. So we're going to do plus map X divided by 8 plus, let's see, map Y divided by 8, and we're going to multiply that by 32. And I think we got Missing, or we got one too many parentheses there, I think. That goes there. And yeah, I just add one more at the end. There we go. So that's grabbing the tile at that location in the map area based on our map X and our map Y. So now if the background data area equals 8800, then we need to actually increment that value. So BGW fetch data 0 plus equals 128. So we're just incrementing the actual ID for that tile. Okay, so now outside of this BGW enable, we need to switch to the next state. Since we're done with that state, we go to state data 0. And we'll fetch x plus equals 8 because we do 8 pixels at a time. When we load that tile data, we're loading 8 pixels of the tile. Let me reformat this some. So now moving on to the data section. So in order to grab the data, we're going to grab that from the bus as well, and we're going to put it in this fetch data section. So fetch data 1 is going to be byte 1, or the bits, in the bits 1, I guess you'd call it. So the one before was map area, this one is data area, because we got the tile from the map area and the actual data for the tile from the data area. And it's going to be kind of similar, but we're grabbing it based on the tile that we fetched. Remember, fetch data 0 is the tile. Multiply by 16 because each tile takes up 16 bytes. And then we add the tile Y. And move on to the next state. Okay, and we're going to do similar for data 1. The difference is we're going to put it in fetch data 2, and we're going to grab tile Y plus 1 because we want to grab that next byte. And we don't want to go to data 1 anymore, we want to go to the idle state. So we can say fs idle. And once we're in the idle state, we're going to just, the only thing that's going to do is just say, okay, I'm done, go to the next state. So push is our next state. This is where we want to actually do the pushing onto the FIFO. So if pipeline FIFO add, and if you read in the docs, it says it's going to keep attempting to push pixels until it succeeds. So it'll stay in this state until it does succeed. So once it does succeed, we are going to go back to our original tile state, and the state machine starts over. And then else, we could say else go to the push state, but I guess we're already in the push state, so we don't really need that. And let's see, I think that's all for these different states. Well, we need to implement this pipeline FIFO add. So let's go up here, I'll add it above this. Pipeline FIFO add. Oops. So if I'm going to copy that, so if the size is greater than 8, this means the FIFO is full and we can't add it. So that's why we need to stay in the push state, because if the FIFO is full, we don't want to lose bits, so we just stay in the push state until it's not full. So let's grab the fetch x minus 8 minus the LCD context scroll x %8. It's because if you remember the sprite with the index x equals 0 is invisible, so really x equals 8 is going to be that first location on the screen. So now we're going to loop through each of those bytes, or each of those bits, sorry. Grab the high byte, and if you remember the previous video when we were drawing these pixels in the UI for our debugger, this is kind of how we're grabbing the pixels. I'm not going to go over how the pixels are stored again because I kind of did that in a previous video. So the high and the low. You know, I'm actually just now noticing this is the high bit and that's the low bit. So, because I'm making this high, I'm shifting that over to the left, but it's alright, it's not a big deal. Just so you know, actually that first one is low and the second one is high. So we're going to grab the color by ORing those two bits together. If you remember, we have 0, 1, 2, or 3 for the different values in there for our tile colors. Yeah, if you remember our display tile, we're essentially doing this exact same kind of thing here. That's why I'm not kind of going over it again, because we already did in that previous video. Okay, so x is greater than 0, we're doing our pixel FIFO pushing that color onto the FIFO. And we will increment our FIFO x. And I think that's it to this one. Oh, return true. Yep. So we want to let this other function know that yes, we succeeded, so we can move on to the next, or to the start state, I guess you'd say. Looks like maybe we declared this wrong. Let's go. Yeah, that should be a bool. Okay, so I think that covers it for these functions. And if you remember, there is one more function that we need to cover, which is the reset. Because when we're done with the FIFO, we need to reset it. So in this one, all we're really going to do is, while its size, so while it has a size greater than 0, we need to pop it off of there. It's going to free it from memory and get our FIFO back in a normal state. We'll set head to 0 as well. And that's probably it. So let's make, got a lot of warnings. Yeah, I guess I just need to forward declare some of these functions. Or I do need to include bus.h as well. So pipeline process and FIFO reset. Now you can put those in, let's say, ppu.c. I could put them in ppu.h, but they're kind of internal, so I'm just going to put them forward declared here. And now that we actually have some pixels in the buffer, the video buffer, let's go back to the UI.c so we can start displaying these pixels. First, I'm just going to paste some of this in here. Again, I'm not going to cover the SDL stuff in depth. This is kind of just a just paste there. And this was created just similar to how the debug screen was created. Yeah, the SDL is kind of out of the scope of this video, but I'm just kind of showing you the code as I write it for the SDL related stuff. You might want to use some other graphics framework, but it should all be relatively the same. So let's start by creating rect. And we're going to kind of zip through this quickly, initializing the rect values, grabbing my video buffer. I need to include ppu.h. So grabbing my video buffer, loop through each of the lines, and loop through each of the x values. Set my rect based on the scale, and fill that rect with the current pixel from the buffer. Now I need to update the texture, render clear the renderer, copy the renderer, and present the renderer. Now let's go ahead and make this and see how it works. Okay, everything made correctly. Let's see if we run. Going to run one of these ROMs, the test ROM. This DB acid. You can see this is the actual rendered image. It's quite a bit of data there. It's just the very first part of this actual test. You can see our FPS there as well. Okay, I'm going to close that. So that test that we're running, this DMG acid, is a special one. I'll go over that in a little while. Let's run one of these other specials. So here's our CPU tests. Remember, we had this debug output that it's printing. Well, it also writes the debug output to the screen. So while it's processing, it stays in this 01-special state, where it just prints out the name of the test that you're running, and then once it completes, you'll either get some failure codes or you'll get a section that says passed once it's done. And this one, it should be almost done. There you go, passed. So actually, we really don't need this debug printing stuff out anymore. I can just comment that out. It'll actually run faster without all that printfing that it needs to do. So let's run another one of these. Let's run maybe 3. And there we go, that one passed. Alright, so let's run something fun here. We'll run Dr. Mario. And look, there's the background of Dr. Mario. It's the startup screen. You'll see there's no dot for the second player, because that's a sprite. And you know, as this loading screen is starting, it's filling things up. You'll see that the pills are magically appearing. That's because they're sprites when they're moving, but they're background objects when they're stopped. So it's kind of interesting to see. Another interesting one that's a simple ROM is Asteroids. If I run that one, you can see it's loading up. And there's Asteroids. And the screens are fading and going to the next screen, so all that's really working really well. These are all just the main loading screens. And now going back to this DMG Acid 2 one. Let's see, that one was a special one for actually testing the PPU. Let me just find it. There you go. That one's for testing the PPU, and the face should look very specific. Let me just search for it. If you just Google, I'll just go in GitHub and search for it. So DMG Acid 2, right here. So this is what it should look like right there for the regular black and white Game Boy. You can see mine's got a little ways to go, but it's pretty close there at least. And there's a bunch of different sections down here, like if nose is missing, you know something's wrong. If certain things are missing, then there's certain parts of the PPU didn't implement properly. It's a good test bed that gives you some ideas on a way to know if you've implemented a PPU correctly. So I think that's a good stop-in point for this video, since we're able to actually display some of the background using the pixel FIFO. In the next video we're going to work on displaying some of the sprites onto the screen as well, and then probably after that we'll move into the window object, which is a scrollable window that you can move around the map. And but anyway, I think this is a good stopping point again, and I hope you learned something and enjoyed this video. If you did, please like, comment, subscribe, and join the Discord channel. And thanks for watching.